Okay, so now here's our first example of a different problem. It says segment SV is split into ratio by point M, and then it gives me the 3 points. So right away, I should think that that's different because I normally only get two of the points, and I have to find the third point, and I have a ratio. This time I have 3 points with no ratio. So, I mean, again, I've said this a million times. When in doubt, I'm going to plot the points and see if I can figure something out. So there's my points. I'm going to label them S, M, V. All right, I'm going to look at them. So I want a ratio of how many parts. Oh, let's see what it says. Let me figure this out. Sorry. I want a ratio of how many parts the yellow is to how many parts the green is. So obviously I can tell green's bigger. All right. But what I would do is I'd be like, all right, well, let's just call SM one part. Let's see how many of those fit into green. So then I'm going to go 1, 2, 1, 1, 2, 1, 1, 2, 1. All right, so it's split up nicely into three parts. So it looks to me like it's one part to three parts, yellow to green. And I'm going to double check and make sure that that's what it wanted. So I've got one yellow part, three green parts. So I've got yellow to green, yellow to green. The only thing that might happen is maybe the yellow was supposed to be two parts, and I have to split it in half. But that would only happen if it was multiple choice and 1 to 3 wasn't there. Like 2 to 6 was there or something, and I had to figure out what happened. So basically, take the smaller one, make it one part, and then split the bigger one up into parts using what you got for the smaller one. All right, so you have to kind of play around a little bit, but it's not incredibly difficult as long again as we can kind of keep repeating slope, which is what